Okay, section 7.2, areas in a plane. So far when we've been doing integrals, we have only been finding the area under the curve, so between the curve and the x-axis. So let's say that we have a function f of x and we want to integrate between a and b, then we're going to find that area. What we're going to do in this section is find the area between two different curves. So let's say between a and b here and here. Then it'll give us this area here. Okay? So let's say that f is on top and g is on the bottom. Then I'm just going to do the integral of f of x minus g of x dx between a and b, which is exactly what this formula is here. So whatever the top function is minus whatever the bottom function is. And of course, if g is on top, then we'll have g minus f. If for some reason they cross in between, so say I have from a to b here to here, well then we're going to have to break it apart. We'll have to do from a to some c value, and then from c to the b value, and then add those together. But that's not until the second part of this section. We're not going to do that in this set of the notes. So in general, if f and g are continuous on the closed interval from a to b, and g of x is less than or equal to f of x for all x in the interval, then the area of the region bounded by the graphs of f and g and the vertical lines x equals a and x equals b is this here. So we can do it either between our vertical lines, or what you're going to see in this section is where your functions are actually meeting at a and b. So if I have this function and this function, then I'm going to have them meet at a and b and then integrate to find that enclosed area between the two curves. Oh, the other thing I was going to say is notice that this says less than or equal to. In this case, in this picture up here, then they're actually crossing, and then f goes from above to below, and g goes from below to above, so we need to split it apart. But if f was just to come down, let's take this graph, just to come down, touch g, and then go back up, well then we could still do that as one integral, okay? Because they're just equal to here, they haven't switched which one was higher and which one was lower. So let's do two examples, and you should be all set. Find the area of the region bounded by the graphs of y equals x squared minus 2 and y equals negative x. So I know what those look like. Y equals x squared minus 2 looks like this. It's just x squared shifted down 2. Y equals negative x is just a line with a slope of negative 1 and it intercepts at the origin. Y equals negative x. So I want the area of the region bounded by those two graphs, so it's between these here. And notice it doesn't matter the fact that part of the graph is below the x-axis because I'm just taking the top function minus the bottom function, and so I'm already accounting for the fact that it's below. Okay, so I'm going to have all positive area. I don't have to deal with that at all. So my first step is I need to find where they are intersecting one another. So I set them equal. So I have x squared minus 2 equals negative x. And x squared plus x minus 2 equals 0. I factor x2, x1 plus minus x equals negative 2 and x equals positive 1. So I don't really even need to get the y values of these points where they intersect one another because I'm going to integrate with respect to x, so all I care about is x. So this x value here must be the negative 2, and this one is the positive 1, the x values of these intercepts. So I'm going to integrate top function minus the bottom function, and you notice the top one is the negative x, and the bottom function in that interval is x squared minus 2 dx, and I'm integrating between negative 2 and 1. So I can't really simplify that at all, so let's just integrate. I have negative x squared over 2 minus x cubed over 3. This is minus a negative, so that's a plus 2. Integral of plus 2 is plus 2x. And I'm evaluating it between negative 2 and 1. And I already did this ahead of time just so I wouldn't have to waste time with it, and I get 9 over 2. Okay, So very, very easy, just like before, top function minus bottom function. I just had an extra step to find where they intersected each other so I could find these bounds of my integral. Okay, let's do one more example. It's a little bit harder. These ones are set equal to x instead of y. Well, that's absolutely fine, right? We're just going to integrate with respect to y instead of x. So notice this one is not a function. Doesn't matter. Let me graph this first. Okay. Y squared, well, that's just like a parabola, just like x squared, only I reflect over y equals x, so therefore it's going to be on its side, and it looks like this. And then I have y plus 1. Well, that's just y equals x minus 1. So it looks like this. So I want the region bounded by those two functions. So that must be this region in here. And again, first thing I need to do is set them equal to one another so that I can find their intersection points. Okay. So first of all, notice this one's a little bit different. In my previous example, I could make these vertical lines, and I'm finding the integral between those two vertical lines. Well, I can't do that here. I'm going from this x value, well, not up to this x value, because my function also comes out to here. So I don't want to do it with respect to x. I'm going to do it with respect to y. Right? I can say that I want it from this y value to this y value. So if you remember when we first started off with LRAM and RRAM and we had our infinitely many rectangles, adding them together, right now I'm just going to think about it like my rectangles are all horizontal because I'm going to integrate with respect to y instead of with respect to x. Right, my previous one, I had all of my vertical rectangles in here that I was adding together. So easy enough. I have, this is obviously my x equals 3 minus y squared. This question is nice because it's already set equal to x for us. And just like I did before with doing the top function minus the bottom function, I'll just do the function that's further to the right minus the function that is further to the left. So this one is to the right. So I have 3 minus y squared minus the function on the left, which is the y plus 1. Okay, and I'm integrating between, well, y equals something and y equals something. So just like before, I need to set the functions equal to one another, and now I'm solving for y instead of solving for x. So they're both set equal to x. Perfect. So I'll set the rest of the function equal to one another. Y plus 1 equals 3 minus y squared. Bring the y squared over here, plus y minus 3, so that gives me a negative 2 equals 0. Y2, y1 plus minus equals y equals negative 2 and y equals positive 1. So this must be y equals positive 1, and must be y equals negative 2. Okay, so now I'm just going to integrate between negative 2 and 1. Okay. Just like before, I'm just going to integrate the function. I can simplify this first because I have two constants here, so negative 2 to 1. 3 minus 1 is 2. So I have 2 minus y squared minus y dy, and I get 2y, right? Just like I would, if it was 2, with respect to x, it would be 2x, so now it's just 2y. So 2y minus 3y minus y cubed over 3, sorry, minus y squared over 2 between negative 2 and 1. And if I plug it in, oh my goodness, it's a miracle. It is also 9/2. Okay. And as it turns out, this is basically the exact same shape, only I have rotated it, right? This whole shape is exactly the same. But it shows you the concepts of integrating with respect to x and with y. Okay, that is it for the first part of this section. We'll have another video on this after you finish with this one. And your homework I put on the back side of this piece of paper so that you don't have to have your books with you. So you just have to do these 3 examples. You can already see that this one is going to be with respect to y, right? That'll be your dy example. And both of these, and yeah, both of these other questions are with respect to x. And how do I know that? Well, if I was to solve for y here, I would get y equals plus or minus square root of x. Now we're looking at, well, the positive square root of x and then the negative square root of x. So therefore you can't even, how do you integrate both functions at once? Well, you can't unless it's solved for x. So you're just going to use the x equals y squared instead. So that is it. And notice at the bottom of the page, I also gave you the answers to these questions, so you'll know whether or not you're doing them correctly before you even come into class next time. That's it for now.